Hello everyone. Today let's solve the problem, design problem basically. Let's solve the design problem here, rate limiter. So we have been asked to design the rate limiter, right? Or the token bucket. We can call this one as leaky bucket as well, right? So here in this case, what we have been asked to do, we need to limit the number of requests that can be processed per client. So here just keep this in mind. We need to limit the number of requests that can be processed per client. So here or client or user or system in the given time window that will be given we will be given or we have been given the certain time window. Within that one we need to limit the number of requests that can be processed per client or per the user or system. So this is often used to protect services from abuse or accidental overload. So they have clearly mentioned here, this is often used to protect services from abuse or accidental overload. This is fine. So next, they have given here subparts or the sub problem here. What are all the things that we need to do? Let's I'll just read out loud so that we can understand that one better. Let's discuss the same thing first, right? So we have to allow up to a certain number of requests per second. See here, rate. So that is mentioned as rate here. We have to allow up to a certain number of requests per second, right? So this is the first one, and second one here is additional requests beyond the allowed rate are rejected. So additional requests beyond the allowed rate, whatever the rate that we allowed, basically this one we are speaking of, allow up to a certain number of requests per second. If it reaches more than this rate basically, then we have to reject, right? Additional request we have to reject, right? So this one, second one. Third one is the implementation must be thread safe, right? We have to keep in mind about the concurrency every time that we write the code. So the implementation must be thread safe, right? So this one we have to keep in mind. So the system should gradually refill tokens over time. So the system should gradually refill the tokens over time. Refill the tokens over time means they are speaking of the refill mechanism here. They have mentioned here, right? Clearly, that is refill mechanism. And the final one here is each client or the requester can have their own bucket. So they have clearly mentioned here, each client or the requester can have their own bucket. Means optionally, right? This is option basically. But we will start with a single bucket. Always we start with a single bucket. So that's what they have given here. This is also known as rate limiter, is also known as token bucket or the leaky bucket, right? So we would have already studied this one. Basically, what do we call? There was something called token bucket algorithm, right? So we would have already studied this one. You guys might be having the idea. So I had forgotten this one. Basically, I'll just go through this one again. So I'll just read out the algorithm and let's discuss the algorithm along with the UML diagram, right? So let's do that. Let's discuss the token bucket algorithm as well as let's discuss the UML diagram first. So let's initially let's discuss the UML diagram first, right? So here let me comment out this one. So just give me a second here. Let's discuss the UML diagram. So here let's discuss the UML diagram first. So this is just the high level overview. Then we will be discussing the token bucket algorithm, right? So here rate limiter, for the rate limiter, as we have already discussed the question, so we know that it should contain certain, it should have certain capacity. Capacity means max tokens that it can hold, right? Max tokens allowed in the bucket, right? Max tokens that is allowed in the bucket. This one I'm speaking of. So attributes I have clearly mentioned here. You can just see here this one, capacity. So this one, capacity will be of the type int basically, right? Capacity will be of the type int basically here. This one, this is fine. Next, it should contain tokens, right? We should have tokens in the rate limiter. Quite obviously, we should be having the tokens. Tokens will be of the type double, right? Tokens means current available tokens. In this case, you can clearly see here. We are discussing the attributes as well here. So tokens nothing but here in this case current available tokens here in this case, right? Current available tokens. So this is capacity. Capacity means the number of max tokens in the bucket or the bucket can hold. So here tokens, current available tokens. Let's move on with the refill rate second. So this was also given in the question itself. They have clearly mentioned. This is refill rate second. We have to consider refill rate per second means number of tokens to be refilled every second. right, number of tokens to be refilled every second. So this is very important as well. They have strictly mentioned in the question as well. So this one, the last refill timestamp. The last refill timestamp. When I say last refill timestamp, it is last time we refilled the tokens. Last time we refilled the tokens. The timestamp we want, right? So this one, this also we are including in the rate limiter. So these are the attributes that we'll be considering within the rate limiter core class. So this one rate limiter class, and this one is the method, basically boolean allow request and void refill. These are the methods that we'll be using within the same class, this one rate limiter core class, right? So just keep this in mind. This is the simple one. Basically, what are the attributes that we are going with? Capacity tokens, refill rate per second, as well as the last refill timestamp. And we have this one here methods. One is boolean allow request, not allow request, which is of the type boolean, and refill. These are the two methods that we will be going, basically, right? Attributes, capacity tokens, as well as refill rate per second and last refill timestamp. Here so let's discuss the token bucket algorithm here. So this has to, or this allows the burst, basically, right? When I say this allows burst, if the user is idle, suppose let's consider the user is idle, right? He's not doing anything. Suppose the user is idle, tokens accumulate at that time. Tokens accumulate and it can be used later, right? So when the user is idle and if he's not performing any action, at that point of time, tokens accumulate and we can use that one. We can use those tokens, generated tokens, later, right? So here in this case, each token equals one request, right? Each token equals one request. So just keep this in mind. Each token equals one request, and bucket holds a max number of tokens, and the bucket holds a max number of tokens. We know this one, right? Bucket, we have been limited to hold the number of tokens in the bucket, right? That shouldn't go beyond the rate. So we have already discussed this one in the question. Bucket holds the maximum number of tokens, and tokens are refilled over time. Tokens are refilled over time. So basically this is the token bucket algorithm, right? So basically this is the token bucket algorithm. Simple, right? So we have already discussed the this one UML diagram, nothing but the just high level overview for the rate limiter, and also we have discussed the token bucket algorithm, right? So now now we are completely familiar with what we need to do, basically accordingly with the question how to design this thing, rate limiter. So accordingly with the UML diagram that we have discussed and the token bucket algorithm, so let's write the code. Let's quickly write the code, and next, after writing the code, let's discuss the complexities and the future scope quickly. Right now, let's write the code first. So first thing here, I'll just go with here public class rate limiter. This is fine. It's the main class, right? So within this one rate limiter class, what we'll do, we have to go with the maximum number of tokens that the bucket can hold. So I'll just go with here private final. This is static, so I'll be making use of the final keyword here on this case, int capacity. So this one, let me give capacity here. This is fine. So the next step here is we have to go with the current available tokens, means that can be fractional during the refill. When I say that, it is like private double tokens. So this is fine. The next one is we are going with the tokens. We have to go with the tokens that has been added to the bucket every second, right? So we have to go with the tokens that has been added to the bucket every second. So I'll just go with here private final. So here this is of the type double, so I'll just go with double refill rate per second, right? So the third attribute we are considering here, refill rate per second. And the fourth attribute was basically last refill timestamp, if you remember the UML diagram. So I'll this one is the last time tokens were refilled. So here in this case, I'll just go with private long last refill time stamp, right? So I'll just go with the timestamp here. This is fine. So why we are getting this one error here? What it states, variable refill, not refill here. This one is refill. Refill rate per second is fine. capacity is also fine. Why this is showing error? Private final int capacity. What error this is saying? The capacity might not have been initialized. So let's do that one later. Let's come here. Let's initialize the same thing here. We have written here last triple timestamp, right? So now let's come to the initialization part here. We'll be making use of the constructor to initialize the bucket. So I'll just go with here public rate limiter in this case. So this will be int capacity. So let me initialize this one. This error has to go here after initialization. So this one int capacity and double this one will be considering refill rate per second, which is of the type double rate per second, this one. So let me go with here double refill rate per second. So this is fine. Within this one, what are all the things that we need to basically initialize? So this one capacity, right? Capacity, this one tokens, refill rate per second, as well as the last refill. So I'll just give here this dot capacity. Let's initialize this one to capacity. This is fine. Then this dot next one we had tokens. Tokens also we are initializing this one to the capacity itself, because this is the first one. This initialization, this is the max bucket size. This will be initially full, right? The bucket will be initially full. So we are initializing the this dot tokens here, tokens to capacity itself, right here in this case. Next, let's go with a refill rate per second. So this dot refill rate per second. Let's initialize this one to the same thing. Refill rate per second. So the next one here is last refill timestamp. So last refill timestamp. So let's initialize this one to the last. So why this is not showing here? This one has to be private long. This is fine. Now this has to shortlist. It's not showing here. What happened here? Let me do one thing here. Last, let me make this one capital here in this case. Timestamp. So yeah, now this is showing. This is fine. Next, I'll just come out of the constructor. So next, let's go with the public method to check whether a request is allowed or not. So basically, we are going with the allow request method, right? So here I'll just go with public synchronized method, which is of the type boolean. So this one is allow request, right? So this is fine. So within this method, what we will do, we'll be making use of the refill. Nothing but we have to refill the tokens based on the time that has elapsed. So based on time elapsed, right? So here I'll just give refill. This is fine. So the next line here is let's go with the simple if condition here. If tokens greater than or equal to 1.0, greater than or equals to this one 1.0, then what we will do, within the if condition, we have to allow the request by using the one token. So here this will be tokens minus equals 1.0. This is fine. We are just allowing the request by using one token. Then we have to accept the request. Nothing but in this case we have to return true. Right, simple to understand. Let's come out of this one. Here in this case, else if the request is not accepted, or if we don't have enough tokens, then we shouldn't accept the request. In that case, we have to return false. So here, yeah, let's come out of the method allow request. So this is it for the allow request. Next, let's go with the internal method to refill the tokens based on the time elapsed. Nothing but refill. We had another method, if you remember, right? Refill. Let's write that refill method quickly. So I'll just go with here private void refill. If you remember this one UML diagram, right? So I'll just go with the refill here in this case. So let me go with here long, now will be the variable name here. In this case, let me go with system. Let me type system here dot. So this one will be nanotime. nothing but we are just getting the current time here in this case by making use of system.nano time. So this is fine. Next step is we, after getting the current time, so let me initialize this one. What do we call second since the last refill? Second. So we have not initialized this one anyway, right? So let me type this one, second since last refill. This one let me initialize to this one is the formula basically. Now minus last refill timestamp. So this one divided by 1 000 underscore 000 underscore 000 dot 0. This is fine. So the next step here is what we have to do. We have to compute how many tokens to add, right? So we have to compute how many tokens to add. Here in this case, let me go with double tokens to add here. This one let me give second since last refill, right? Second since last refill into refill rate per second. So let me give this one. We are computing how many tokens to add. So after computing how many tokens to add, we have to go with the cap at max capacity. So we have to go with the cap at max capacity. So I'll just consider tokens here. Let me initialize the tokens too. So math.min, we have to go with the cap at max capacity, right? So we have to consider the capacity in this case. So what happened here? Yeah, let's consider capacity along with tokens plus tokens to add here. So let me consider tokens to add this one. This is fine. So after this one, what I'll be doing here is we have to update the last refill time. We have to update the last refill time. Nothing but in this case, last refill time. This one, let me assign this one to now. We are just updating the last refill time here, right? Now let's come to the main part here. Let's write the main function. We need to get some output, right, based on the code that we have written. So let's come to the main function here. So here let me give quickly public class. Let me give main here. So main, what we considered here, the name basically rate limiter, right? So I'll just copy the same thing here. So rate limiter. So within this one, what we will be doing, so we don't need this one at all. I think we have already considered the main this one, right? So let me do one thing here. So here let me give public static void main. This one, this is fine. String arguments. So this is fine. So within the main this one, what do? We are getting max 5 tokens and two tokens per second. So you can take any number. Just for the sake of example, I'll just consider here rate limiter. So basically the variable r1 which is of the type rate limiter. Here in this case we will be creating new tokens, right? So here the rate limiter, so let me consider here rate limiter. Let me do one thing. Let's pass the max 5 tokens, 5 comma 2 tokens per second. So here I'll just give 5 comma 2 in this case, right? This is capacity 5 and refill rate per second is 2, right? So this is fine. So the next let me write the simple for loop here. And I equals 0, I less than 10 and I plus plus here. This is fine. Within the for loop, what we are doing, if r1 allow request is nothing but in this case this one. So we are going with the method allow request here, right? So allow request, this is fine. Let's print something right here in this case, whether it is allowed or not. In this case, let's check the same thing here. I'll just we are printing something right here. I'll just go with s out here. So let me do one thing here. Request, let me do one thing. Give this in capital. Request plus I, we are concatenating the I here, plus allowed. So we are going with the I less than 10. Right, I starts from 0. I less than 10 means 10 requests we are going with. So here, that is the reason we have concatenated I here. Allowed. Else, what we will do in this case, let's print something if it is not allowed, right? So in this case, request, let's concatenate the I here. In this case, I'll just give rejected. So this is fine, right? Rejected. It's fine. So the next step here is what I'll do. Let's simulate the 300 milliseconds delay between the requests. So I'll just go with here. Let me make use of thread dot sleep 300 milliseconds, right? We are simulating the 300 ms. This one delay between the requests. So I'll just go with here thread dot sleep of 300. So this is fine. This is nothing but the milliseconds. We are just simulating the 300 milliseconds delay between the requests, right? So this is it for the code. So here in this case, just give me a second. Let me format this one once. So the code works, looks good actually. Here in this case, let's check whether we have any error. So we don't have any error, right? So what is the error here? Thread.sleep unheld add exception to the methods. This is fine, right? This case it has to work. Thread.sleep. We have given here 300. This is fine. Apart from this one, this is just this one. Rate limiter sync package or.example.rate limiter. This is fine. This works without that as well. So in this case, before running the code, so the bucket capacity we have given here as 5. See here, 5 we have given here, right? So the bucket capacity is 5 and the refill rate is 2. This one, refill rate per second. Bucket capacity is 5, refill rate is 2 tokens per second. So delay between the this one request is 300 ms, nothing but the 0.3 seconds. This one I'm speaking of 0.3 seconds. So after each request, accordingly with the formula we have mentioned, about 0.3 into 2, nothing but 0.6 are filled. In the 5 requests, approximately 3 tokens are refilled already, right? In the 5 requests, approximately 0.6 into 5 means 3, right? In the 5 requests, approximately 3 tokens are filled already. So we have requested 0 to 4. We are consuming initial 5 tokens basically. After each request, refill adds back 0.6 tokens, which allows the next request to go through, right? In this case, so over time what happens here is the refill rate keeps up with the consumption, because consumption, sorry. So here we have 300 milliseconds delay, which basically allows for the partial refill, and also refill accumulates between the requests, right? So refill accumulates between the requests, right? So all the 10 requests are allowed here. In this case, we don't get any error here. Will not get any rejection, right? So all the 10 requests from 0 to 9 will be allowed, because initial 5 tokens are consumed by the first 5 requests. We have discussed this one. And 300 milliseconds delay, 300 ms delay here between requests allows partial refill. In this case, 0.6 tokens per request, right? So the partial refill accumulates and keeps the token count from depleting in this case. So subsequent requests are allowed as refill almost equal to consumption rate, right? So let's check the same thing here. From 0 to 9, we have to get allowed for all the 10 requests, right? From 0 to 9. So let's check the same thing here. What happened here? As refill timestamp cannot find the symbol. So what is wrong with here? So this one has to be capital R. Last refill timestamp. Then what here? So just give me a second here. Variable is already assigned to this value. Okay. So here let me run this one again. Let's see. Unreported exception Java must be caught or declared to be thrown. So here in this case, we have this one I rejected. This is fine. This one thread dot sleep of what's wrong here? This is correct itself, right? We are just given here thread dot sleep of 300. We are just simulating 300 milliseconds delay before between the requests here. What's wrong here? Dot sleep. Let's see what is wrong. So here what mistake I have done here is, so here the last triple timestamp we are assigning to this itself, right? So that's what it was saying here. Variable is already assigned to this value. So let me do one thing here. This one we have to assign to system dot nano time here in this case, right? Now this has to work. Let's see. Let me hit the run button again. Unreported exception. So again, let's see what. So here it is asking us to give the uninterrupted exception, right? Let's do one thing. Let me paste the same thing here. Whether I don't know whether this works. Let me give here throws interrupted exception right here. So let me run this one again. I hope this works. Let's see this time. So yeah, now you can clearly see. Yeah, for 300 milliseconds it is taking for every request right here. Request 0 allowed, request 1 allowed, all the 10 requests has to be allowed. We have discussed this one. Request 0 allowed, request 1 allowed, 2 allowed, 3 allowed, 4 5 6 7 8 9, 0 to 9, basically 10, right? So all the requests are allowed. Now the code is working absolutely correct in this case. The code works absolutely correct in this case. This we had to include, basically throws interrupted exception here, right? Because we are making use of the thread dot sleep here. So this is fine. Now this works absolutely correct in this case. Let's quickly discuss the complexities for the methods, right? Two methods that we have written, right? Let's discuss the complexities for the two methods, and then let's discuss the futures. So let's discuss the complexities very quickly here. In this case, the time complexity for the allowed request method, this method allowed request method is big of 1, and the space this one refill method, for the refill method also the time complexity is big of 1. These are the two methods that we have used in the rate limiter class, right? So allow request and refill method, the time complexity is quite obviously big of 1, and the space complexity is big of 1 as well, right? The time complexity and the space complexity is big of 1. Space complexity is big of 1 because we are just making use of few variables right here in this case. So let's come to the last part, design considerations or the future scope here. Let's go with the design consideration. So first part is concurrency here. When I say concurrency, we are making use of the synchronized. So we have made use of synchronized. If you remember the code, right? We are going with the synchronized method to ensure thread safety. So we are going with the synchronized keyword just to make sure that this one just to ensure thread safety. Next, let's go with the precision. So we have went with the system.nano time, right? So we have went with the system.nano time for the better precision, right? So this one we have made use of system.nano time for the better precision. And about the refill granularity, whatever I have written here, refill granularity here, this supports fractional refill per second. This supports fractional refill per second. So the fourth one here is burst handling. When I say burst handling, bucket can store tokens during the idle time, right? So buckets can store the tokens during the idle time. When the user is idle, buckets can store, if the user is not performing any action when the user is idle, bucket can store tokens during the idle time, right? And then we can use the same tokens later. So next one, the final one is extensibility. When I say extensibility, it can be extended for per user rate limits, right? So this is the extensibility part. So these are the things that we have kept in mind, then we wrote the code, right? So this is the design considerations basically. So we have discussed the complexities for the code that we have written, and also finally we have discussed the design considerations as well. We have successfully written the code as well. Now we have successfully solved the rate limiter design problem. So this is it. Thanks for watching, guys.